call is being recorded. And now to begin the program, I'd like to introduce Chris Flack.
Hey, thank you so much, Jennifer, and welcome everybody in the audience to today's webcast, Remote Desktop Services Expanding to Past One Server, sponsored by Kemp. I'm Chris Flack with Redmond Magazine, and I'm just going to be your brief opening host for today's webcast, so thank you all for joining us. Just a few quick things before we start today's webcast and introduce today's speakers. We will have a Q&A session at the end of today's webcast. Please feel free, however, at any time during today's presentation to ask a question using the Ask a Question box on the left-hand side of your console. And hopefully, if time permits, we'll get to everybody's questions and supply some answers. But don't forget, you can submit your questions at any time to us here and the webcast. Also, this webcast is being recorded and archived for future viewing and listening purposes, and we'll send you a link within 24 to 48 hours after today's webcast where you can view the replay. And please feel free to share that link with coworkers and friends who may be interested in the topic as well. Joining us for today's webcast, we have two great presenters. Later on, you're going to be hearing from Jonathan Braunhunt. He is from Kemp Technologies. He is a chief scientist there. He has over 25 years of IT experience with primary focus on networking and security. His first PC was IBM at Hotwired with an 8 megahertz crystal. He's also former director at New York office of the Comptroller. So that's excellent. But joining us first today, we're going to have Greg Shields, who's a senior partner with Concentrated Technology with over 15 years of experience spanning the breadth and depth of IT. He's a contributing editor and columnist for TechNet Magazine and Redmond Magazine and serves as a conference chair for TechMentorEvents.com. He's authored countless books and white papers and articles and can be regularly found sharing expert advice on webinars just like this one today. And with that, I'm going to hand over today's webcast to Greg so he can get us started. So Greg, the floor is yours. Take it away, my friend.
Thanks, Jonathan, and thanks also to all of you. Once again, getting together to talk about these newer technologies. And I have to admit that today's topic is one that is near and dear to my heart, remote desktop services. Partially because, RDS is one of those technologies that's been around for a long time. I think I started working with RDS back in the days before it was RDS, when it was in the NCD WinFrame days, when you can think about the old Citrix technologies. And so RDS is one of those things that has been around for a very long time. It's a mature technology. It's a well-defined technology. It's one that's seen a lot of enhancements. But you can't really get away from some of the notions that RDS itself, even today, still has some interesting limitations, especially when you start trying to, as the title of this webinar says, expand yourself past one server. For the entire history of RDS and the technologies that exist in RDS, getting one RDSH or terminal server up and running was a fairly easy thing to do, but trying to go from a single server to more than one server is one that, there was just a significant additional amount of effort that was involved. So today what we're going to talk about is not only just RDS, but mainly some of the load balancing solutions that exist that you can use to actually expand past one server or to expand to many servers, maybe potentially even into multiple sites. And so that's our exploration today. We're going to spend some time here. I've got Jonathan Braunhunt here from our sponsor, Kemp Technologies. In just a minute, he and I are going to spend a little bit of time talking about just what those load balancing solutions for RDS may actually be. Now, I got to start, however, with just this recognition that, RDS really is a powerful technology for delivering applications. I mentioned before, this is a technology that's been around for over a decade, probably almost 2 decades at this point. And so as that powerful technology, we see it pretty much everywhere. Right? It's mature at this point. The RDS protocol has seen significant enhancements in performance. So it does very well at enabling those applications to exist even over latent or slow or narrow bandwidth connections, out onto the internet, out onto intranets as well. That also, that presence anywhere on the internet, anywhere with a network connection, means that RDS can deliver applications pretty much anywhere, making it a very universal technology for getting access to people that you need wherever they may be. Now, as I said, that the RDS technologies have for a very long time been kind of deceptively simple in the beginning. It's very easy to build and operate that single RDS server. When you have to go to more than one, well, that's when things start to get a little bit difficult. So the scaling past even just a single server becomes kind of a hurdle for many people who want to implement RDS technologies. So when we make those changes, and when we go from one server to many servers, or even one site to multiple sites, things get non-linearly more complex. We have to add additional web access servers, or RDWAs, and we have to add additional gateways, additional service hosts, potentially even connection brokers. And these can be tough to load balance. So there are built-in tools, but based off of many of the use cases that I think you are here to hear about today, it makes you might wonder if the built-in load balancing tools work well enough to support those use cases. So I want to spend some time here while we're all kind of collected here to talk a little bit about some of the tactics that do exist in load balancing RDS. And first and foremost, John Braunhut is a chief scientist from our sponsor today, Kemp Technologies. And I want to say, John, thanks for spending some time to talk with us today.
Greg, pleasure is all mine. You know, I'm thinking back to your start in thin clients, back to the old NCT WinFrame days. I too cut my teeth back in the early 90s with Citrix and WinFrame, and don't see much of that today, but got a mother-in-law who lives just 2 miles from their former headquarters, so there's a bit of nostalgia when I say that.
I remember the original administrator's guide for NCT WinFrame was an 8.5 by 14 sheet of paper folded over and stapled in the middle. And I think it was maybe 5 or 6 sheets in total. And I think I still actually have that original administrator's guide because it was just that impressive. So John, we're here talking about RDS. We're here talking about load balancing. Talk for just a minute about, all right, why do we need to load balance RDS servers?
Well, actually, the first question you have to ask is that actually what you're looking to do? Because when folks are thinking about going from one, RD session host to more than one, there's 2 different clusters of thinking. There's thinking about scale out. I'm out of capacity and I need to scale wide, and now I need to load balance that. But the other line of thinking, and this is common with a lot of Kemp customers, is they're looking to go from 1 to 2 servers, not necessarily for scale out, not necessarily for capacity, but because they've got a mandate for business continuity and disaster resilience, and they want their 5 nines worth of uptime. So it's important to be clear in your head. Are you trying to do true scale out, or is this really just a business continuity DR kind of thing?
So I'll ask you then, are there differences in deploying multiple RDSH servers for either the HA use case or the scale-out use case?
Well, it turns out that the HA use case is more limited, and because it's more limited, it's also simpler. If that's truly all that's required in an environment, it lets you avoid a lot of complexities. You can look towards solutions that give you an active, passive approach to your servers where I'm going to be on my primary server unless a ghost hose up, and then I'm going to switch over to the other. You don't have to do much in the way of connection tracking. You don't have to do much in the way of authentication manipulation to make that sort of solution work. It's key to note that when you have a true scale-out, then you have to also provide for adequate capacity in the event of a terminal server failure. If you go from 1 server to 2 servers because you have a capacity crisis, if you should have a health problem with one of your servers, you're going to be at 50% capacity, and you have to then say, well, gee, is the quality of service, the rated quality of service I'm going to be delivering, is that going to be acceptable? Is that going to let me meet my SLAs? Is that going to keep the folks productive and useful? You have to also sort of size what you're doing to handle that scenario.
I can think that not only is the high availability use case somewhat different than the scale-out use case, but there are also going to be various different reasons why a remote application infrastructure exists. Right? We deploy RDS for a lot of different reasons. One would be the classic person in a cube farm somewhere who needs access to an application. Another may be a roaming user, or even a kiosk user. Do you see special issues in the load balancing, in a question of load balancing? Do you see special issues that need to be addressed when you got lots of different RDSH servers and that are supporting roaming users or kiosk users, for example?
The roaming kiosk case is a fun one because that's where a lot of the less technologically mature solutions fall short. With a roaming user, you can pretty much guarantee that there's not going to be guaranteed layer 4 IP address stability. People roam from floor to floor, from building to building, from network to network. And what you do then need is a way to track connections at the session layer, at the authenticated layer 7. This is who's coming on the network. So certain types of naive solutions like DNS round robin, unless they're also matched with good persistence handling mechanisms, will fall short.
So talk for a minute. I know that I know some of the limitations about DNS round robin, and I'm sure you do as well. Talk a little bit about those limitations, right? If I have DNS round robin, I'm putting a set of host names into DNS, but I can imagine that, it's going to create some limitations, especially if I start losing servers, right?
Right, because a round-robin DNS limitation is really server farm unaware and it's health unaware, and it'll bring people in a nice ordered fashion to one server and the next and the next. But if there is a circuit interruption or if there is a server failure, there's going to be some fraction of users who pick up the meanie on eeny, meeny, miny, mo, who may find themselves in trouble. So if you're
as I can imagine, if you end up losing a server, round robin is just going to send people back to that same server. It's not a very intelligent solution for load balancing.
It has simplicity as a virtue, but it's not intelligence, and it sort of makes a built-in assumption that you've got an ultra-reliable infrastructure, and the real world tends to confound those expectations.
It's kind of interesting too when you look at Microsoft's documentation for load balancing RDS. It has kind of a heavy focus on using round robin, where when you start getting into more highly available requirements, that it's something that won't necessarily be supported. In fact, so one of the other problems with round robin is the fact that it's exactly that. It is round, and so it ends up distributing out those users in a fairly equal way. Well, that can actually be somewhat of a problem. So if I have every machine that is exactly the same and can support the same number of users, that's one thing. But not every machine, not every server is exactly the same. Some may be a little bit different in the resources they have, or even the types of activities that are being done on those servers can be somewhat different as well. Users on server A may be running through a spreadsheet, not doing really all that much activity, and on server B, maybe somebody's using a CAD tool or a modeling tool, and they're using all kinds of resources. How in that situation, or either of those situations, can you ensure fair allocation of users across those different hosts?
Wow. There's lots of ways. Microsoft themselves is looking at that problem, and at least at the server level, I think they've done a very nice job with the new fair share CPU scheduling. That's really a cool thing that they have. And within a single server, I think they've done a good job of making sure that sessions that exist on a single server get the slices they need. Of course, the problem is that technology doesn't really encompass what happens when you have a terminal service farm and you now have to allocate resources fairly across multiple servers. In that case, some sort of WMI integration, some sort of integration where you can actually look at server resources and see CPU usage, disk usage, network usage, memory usage. The more visibility you have into a terminal server, the better job you can do of allocating the next user that comes in, not necessarily in a round-robin fashion, but to the least utilized server.
Sounds like whereas even the Microsoft's built-in solutions, those above load balancing, are more of still a layer 3 approach. What you're talking about is more of a layer 7 approach in that it has the intelligence built in to see when the conditions are not exactly ripe to add another user to that machine. I want to talk for a minute about, all right, so we've discussed, I've got a bunch of hosts. And in most of our discussions at this point, we've talked about those hosts being in a single data center. But today, there are many organizations that are branching out beyond just one single data center. We may have multiple data centers across the country or even across the planet. And this notion of, I'll call it global load balancing, but just multiple data center load balancing, can actually get somewhat challenging, particularly if you want to provide a single namespace for all the people to connect in. Are there techniques or technologies available today that allow you to deploy multiple RDSH servers in multiple data centers and yet still provide that single namespace to make things easy?
There sure are. At Kemp, we've been offering both server load balance solutions and global load balance solutions for a number of years, and I guess I feel a little red-faced because we were just sort of dumping on good old DNS, and it turns out that round-robin DNS isn't much of a way to get things done. But when you do have multiple sites that you want to access with a single namespace and have some sort of site resilience, then DNS coupled with good visibility and access to site health and server health does turn out to be a good way to get people to a data center the whole life storm.
So for those of you that are paying attention along at home, if you do have questions, there should be a Ask a Question box somewhere on your screen that gives you an opportunity to interact with us. John and I are going to be here for as long as we can, answering as many questions as we can. So if you have one, feel free to pop one there in the Ask a Question box, and we'll see if we can get to it here in our conversation today. So, all right, there is this notion of global load balancing, but in order to support getting users in from wherever they may be, we've got to have some sort of technology that secures that connection. Right? So inside my LAN is one thing, but if I start to extend those RDS applications out onto the internet, well, I've got to have security that's out there. Built into Windows is this role service we think of as the remote desktop gateway. And RDG, fairly simple solution. It essentially exists as a kind of proxy between the inside and the outside, but in many ways could be just a single server solution. As I think about this and what we were talking about earlier with scale out and high availability, if I need to have high availability, or if I need to have scale out for RDG, do I have to deploy multiple RDGs?
Well, that's, I guess, why we started talking about, understand why you're deploying these extra servers. The extra workloads that often motivate people to scale out their session hosts don't necessitate scaling out the RDGs. RDGs tend to have a much higher dynamic range, and I've seen people go 3, 4, 5, 10 session hosts even on a single RDG gateway without running much of a sweat. But if the high availability does become important, then you have to start looking at doing a good job of load balancing the RDGs. RDGs are a nice target for load balancers because as folks in the load balancing business know web protocols like 443, and of course the thing with an RDG is it's just terminal services wrapped in a nice, crispy, crunchy SSL 443 wrapper.
So with a set of servers, right? So I've got these RDSH servers that are out there, and I've got them deployed, right? And I have load balancing set up. Are there ways that one could set, user expectations, SLAs, uninterrupted service, just these guarantees? How do I ensure that the environment that I set up is one that will support those high availability needs?
Okay, that's a great question. And that expectation setting is really crucial because if you've got a user who's doing a complex financial model where they get recalc on their Excel spreadsheet and expect to go get 2 or 3 cups of coffee before the result is returned, and if there is a failure on the server that's been crunching that spreadsheet in the data center, regardless of whatever sorts of load balancing or high availability solutions you've got, we still aren't at the point where we're going to be able to do true stateful high availability, so that spreadsheet recalc is going to have to be repeated. So when we're talking about high availability, we're talking about the ability to pretty much get back to a good, known, logged-in desktop state quickly and to minimize the amount of downtime that a user has to spend waiting to be able to get a session somewhere.
So I have a question here from Stalin. Is there still a session broker involved? I know you guys are sponsoring this webinar here. If we're using a hardware-based technology like Kemp, is there still a session broker involved?
That is a beautiful story because we will interoperate with a session broker, and we have a mode where we will basically do the load balancing. We'll do the health checking, but we'll leave the persistence and the affinity relationships to the connection broker, and we'll work hand in hand with Microsoft's connection broker tokens. Conversely, for some simpler environments where people don't want to take on the overhead of that full extra layer, we can replace a connection broker and actually maintain those persistence and affinity relations ourselves, in addition to the layer 7 health checking that we do and the good fair distribution of traffic that hardware load balancers are known for.
So I guess maybe there's some confusion in my mind here. The activities that a connection broker does and the activities that a load balancer provides, even whether it be a hardware load balancer or whether it be just anyone that's available out of the box, these two provide different portions of that sum total of experience. Can you spend a minute kind of talking about the differences between those two?
Oh, sure. Okay, so if we're running the Microsoft playbook and we're using the remote desktop connection broker to handle user session to server affinity, there's actually deep inside DNS round robin as the load balancing technique. That's fundamental to the pure play Microsoft infrastructure. And of course, DNS round robin means no true service-aware health checking, and you have that problem with black hole users that don't easily get yanked out of that black hole without heroic efforts. Whereas with a load balancer that knows how to do good, fair allocation based on server metrics, and that knows how to do session-aware health checking, we're perfectly content to give the visibility and the metrics and the reporting that you can get off of a connection broker. Frankly, it's difficult in the context of a load balancer to give folks good visibility on which user is on which server. Turns out that the connection broker is a perfect place to just have runtime operational visibility on that. So it really is a question of 1 and 1 is 3.
Josh actually asked a question about, so there's this, in one sense, you can implement RDS, and as you start implementing multiple hosts and multiple session brokers and all this extra complexity with RDS, he kind of asked the question, well, why wouldn't I just jump to something like Citrix? And it makes me think that, so the use case can be different for why one would implement all the extra pieces of that extra Citrix platform, as opposed to would one just needs a load balancer. What comes to mind is the idea that a load balancer can support, for example, more than just RDS, right? A properly configured load balancer can, honestly, it can load balance really any traffic that comes in if it's appropriately constructed. So look, the question to you is, all right, can a load balancer, a hardware load balancer, be used for other Microsoft applications at the same time it's being used for RDS?
Not only can it, but that's really and truly the most common use case. Folks that are doing RDS tend to be, in various degrees, Microsoft committed shops. And there's going to be the the full array of Microsoft shrink wrap workflows, Microsoft Exchange, Link, SharePoint, and a multi-service, multi-function load balancer is capable of concurrently handling flows for RDS as well as the flows for the other big back-end applications in the data center. Nice thing about a hardware load balancer also is that there's a good amount of network flexibility, lots of ports, lots of VLANing and features that allow you to place a single or a pair of load balancers in an infrastructure and not have to alter your intended topology to make that all work concurrently.
In fact, you are from Kemp, and obviously Kemp creates a load balancer. So I know you've got a couple of slides you want to talk about that talks about the Kemp solution in doing load balancing for RDS. Why don't you go ahead and take a minute and show us some of these slides that you have?
That would be my pleasure. Thank you very much, Greg. So we've been talking today about different approaches to RDS and scale out and high availability. And what we're showing here is really just one sort of typical example configuration for how folks might want to approach that with a Kemp LoadMaster. And again, just to sum up the big points that we've been talking about, with a hardware load balancer like a LoadMaster, you do get true service-aware health checking. We're not just going to be pinging to see if the host is up. We're actually going to be interacting at the RDP layer to make sure that the RDP service is doing what it's supposed to. We can and do integrate with Connection Broker so that you can leave the affinity relationships on the Connection Broker while we take care of the good load distribution and the good health checking. Layer 7 persistence if you choose not to go with the Connection Broker. And again, the resource-based LD agent, that's what we referred to before when we talked about visibility on the WMI components and the ability just to see CPU, disk, memory, network, and make sure that we don't send a new user to an overtaxed server. This is a little more of how we do it. The health checking that we do from a LoadMaster is actually attempting, the LoadMaster itself will attempt to initiate an RDC connection to each of the RDSH servers in the farm. And what we're looking for is handshaking and positive response that, yeah, there is a true RDSH session available for us. And only then do we keep that server in the pool for distributing traffic. Okay, what just happened here? I think I clicked too far. There we go. Okay, so there's a whole multi-step process that's involved with the LoadMaster when we do integrate with Connection Broker. In step 1, a VPC client comes in, wants to establish a new session. The LoadMaster will either use round robin or use its WMI awareness to figure out which servers should get the next session. And then the LoadMaster will go and talk to the Connection Broker and say, hey, is this guy coming in here? Is this an established connection or a new one? If we find it's an established connection, we're going to continue that connection, because one thing we don't want to do is we don't want to disrupt users who've got established connections. That may be the kiosk scenario we talked about before where somebody's roaming, and we want to honor that. If the Connection Broker says, hey, I don't know this guy, then we've got a new connection. We tell the Connection Broker to set it up, and we exchange routing tokens and put the client connection on the server that's best for it. Without a Connection Broker, we can maintain that Layer 7 RDP persistence relationship. We can actually read into RDP, and we can see usernames and domains as connection requests come in. So we can, in this scenario, do it all without Connection Broker. We can find the right server, we can maintain the right association, and we can keep only healthy servers presented without necessarily deploying the Connection Broker role. We're going to get back to that one in a second. Connection-based load balancing. Most load balancing solutions, including Windows network load balancing, are only able to distribute connections based on RDP connection counts, and they're not aware of the actual load chain. We talked about heterogeneous user workflows where some folks are just doing very simple, low bandwidth, low CPU data entry, while other folks are doing the CAD, CAM, and the multimedia and the compute-intensive work. When you have mixes of users like that, even though you may have the same number of user counts on each of your servers in a load balanced terminal server farm, one server can have a horribly overtaxed CPU just by sort of law of random numbers, where others are vastly underutilized. Whereas if you take a LoadMaster and you put our proprietary adaptive agent on each of your terminal services, the adaptive agent is the glue that gives the LoadMaster access to all that WMI information, all those metrics on each server, so that you know your server farm and you know where the stress points are on your servers. You reflect that in the way you configure the agent, and the LoadMaster then honors that, and rather than put the same number of connections on each server, we'll put the same amount of load on each server so that folks get the best possible experience with the totality of the infrastructure that they've got. And what I'd like to do now is talk a little in general about Kemp, the company, and sort of who are we to sponsor this, and why are we the right solution for load balancing RDS? Well, we're the right people because we've got the right experience and we've got the right product and support folks that stand behind it. We have a product line that is solely stratified by size, and there's always a right size LoadMaster for any size terminal service farm, and we just think we've got the number one price feature ratio in the business. So why are we the right company? We've got over 6 million. One day. Today, that we've got over 6,000 deployed load balancers that are being used primarily for Microsoft application flows. And again, that encompasses the whole world of Microsoft products, terminal services, SharePoint, Link, Exchange, other Microsoft-specific high availability, and also scale-outs. We even have in the LoadMaster a special just for terminal services server type baked right in. So if you tell LoadMaster, hey, I'm setting up a virtual server for terminal services, it already knows about RDP, it already understands how the authentication is going to work, and there's really not a whole lot of configuring or fussing around you have to do. And that's because we tried to make the LoadMaster accessible for the IT generalist. Folks that have the problem of going from one terminal server to two, many of them tend to be generalists and have to wear a lot of different hats, and we don't expect folks to become load balancing experts in order to be able to be successful in production and in operation with a LoadMaster, nor frankly do they want to be. There's lots of hours in the day that they need for other things. The 1 year of support is a big value add that we offer at Kemp, and it comes free with every LoadMaster. It's email support, phone support, forum support, as well as regular firmware feature updates. Our support guys do know their stuff, and they do know how to speak RDS. And we've been talking in this presentation about the server load balancer, but I think we did touch briefly upon data center resilience and site resilience. And we do offer complementary to our load balancer, LoadMaster line, something called the Geo LoadMaster, which is our dynamic, service-aware, health checking, DNS responder that integrates with Microsoft DNS, it integrates with third-party DNSs, and allows you to do good high availability for site to site. Okay, LoadMasters start as low as $1,500, and they are stratified strictly based on size and performance. Every LoadMaster, from the littlest guy up to the biggest, is feature complete and has the full complement of enterprise level load balancing features, the service-aware health checking, HTTP caching and compression, SSL offload and re-encryption, IPS for intrusion detection and prevention. Again, you don't go to Toyota and get a Camry that doesn't have power steering and power brakes. You know, every Toyota has the same thing. It's just how many cylinders do you want, and the question is, you know, how many gigabit throughput do you want? How many ports do you want? That's how we're going to stratify the LoadMasters. We were honored late last year to be named by one of the leading analysts out of 12 leading load balancer vendors. Kemp was one of only 2 hardware load balancer vendors scoring as the highest value leader in a report by EMA. And again, it's kind of blush-worthy, but they said, look, we've got a solid set of features that meet the needs of the target solution demographic. Our sweet spot is the small to medium business guy who just needs to cover a wide range of application spaces and needs to keep it simple and needs to keep it up. Kemp Technologies. We've been in business over a decade, got established back in 2000. We are a global organization. We've got headquarters in New York, European headquarters in Limerick, and we just opened an APAC office in Singapore. That's our 3rd headquarters, so we are truly targeting follow-the-sun support and having a worldwide presence. Grown almost 500% over the past 5 years, and we are the leader in load balancing for small and medium business. We offer both layer 4 and 7 load balancing. Again, we've got, I talked about this before, the SSL offload and acceleration, the service-aware health checking, the advanced HTTP features folks want. LoadMasters themselves can be a single point of failure, so we do have a simple to deploy, active hot standby, high availability technology that lets you put 2 LoadMasters together in tight sync with no more than a crossover cable. We also do have application-specific templating, including Exchange and Link, and I did talk about before the virtual services that are actually RDP aware with just a click of a button. We've got a lot of LoadMasters in distribution and on our shelves, and as bits for download. And if you want a hardware version, you can get one free of charge at the URL we're showing here. And if you like it, license is yours, and if you don't, give it on back. If you don't want to take on our atoms, you can take on our bits by downloading a free trial of the virtual appliance. These are no obligation evaluation units, whether they're physical or virtual. We've got general trial offers because we know that once people get this thing in and get their hands around it, they're not going to let it go. And that's our story.
All right, great.
Thanks, well, thank you. And I think at this point, if you for those of you that are participating, if you have any questions for either myself or for Jonathan, feel free to type those into the Ask a Question box found on your screen. We've got a couple of questions that have popped in here now, and let me just see if I've got a couple here. I know there's some that are for you, Jonathan. Chris asks, besides price, why would one choose the virtual appliance over the hardware device or vice versa?
Great question. And it shows that Chris has been paying good attention, because with the feature functionality parity, you guys say, well, why do I do one or the other? And it really has to do with a few things. First of all, obviously, if rack space is at a premium, you might have a preference for something virtual over something that's going to take another couple of inches in the rack. Beyond that, there's also, some organizations have a mandate to virtualize everything. They're going to consolidate everything in the virtual spacing, and we offer the virtual appliance in order to best dovetail with folks that have that sort of operational mandate. But the hardware load balancers do themselves have certain advantages over the virtual, because as dedicated appliances, we understand the experience we're offering. We can make a claim. We can say, if you get our top LoadMaster, you're going to get almost 9 gigabits of sweet load balance throughput, regardless of what else is going on in your data center. In the case of the virtual appliance, you may be able to achieve throughputs that are close to that, but you're going to have to much more carefully manage your virtual environment to make sure that there's adequate hardware resources available to the virtual LoadMaster to accomplish those kinds of goals. So in general, I'd say if you're at the lighter capacity end of the spectrum, it's really a toss-up. Do it for price, do it to save electricity or to save rack space. If you're looking at larger flows, you might want to think about whether you want to take on that additional virtual environment resource management that's going to be needed to get the best performance out of a virtual LoadMaster, as opposed to just getting one of our big pieces of iron.
I've got another question here from RF. He's asking about one of the models that you have, the VLM100, and his question is a little inspecific, and so I'll sort of add to it. But I think his question relates to all the things that you've talked about here, about all the different feature sets that are supported. Can the VLM100 actually support those feature sets?
Absolutely. 100% I'm going to get this out. 100% feature parity across the entirety of Kemp LoadMasters, be they virtual or hardware. So yes, you can use the VLM100 to do everything we talked about and illustrated today.
Which I think also answers Niranjan's question. He says he's using the VLM for his Exchange environment, and the assumption is that he can use the same appliance to do RDS without having to purchase a separate device.
He may well be able to, and here I'm going to draw a distinction. This now depends again on what virtual platform you're running on. Kemp virtual LoadMasters actually run on quite a few different hypervisors. We're solid in the VMware space, VMware 4 and 5. We have coverage for Hyper-V for Windows 2008 and 2012. And our latest release now covers many flavors of open source Zen. So the question about doing multi-service with a virtual LoadMaster is really going to depend on the networking and whether you've got your virtual switches designed for the hypervisor of your choice in order to let that singly located virtual LoadMaster get to the subnets and get to a segment that it needs to for doing both Exchange and terminal services. In general, our customers that are doing virtual tend to deploy more point solution-specific VLMs, so that's a matter of taste. It's a matter of preference. It can often work both ways.
A great question from Tom. Tom asked the question, so he's looking at the use case, and he's comparing the LoadMaster with Layer 7 RDP persistence versus Microsoft Connection Broker. In his mind, he sees the L7 option as being easier to deploy and manage, but can you talk a little bit more about the functional differences?
There are indeed functional differences, and I want to stress that they're not identical. When you have a connection broker in place, you do get visibility on the user session to server relationship in real time in operations. That's not impossible to get on a LoadMaster, but it's a little more difficult because go through logs to figure out those relationships. And if your help desks are plagued with calls of users having problems, sometimes it's nice to have that visibility through Connection Broker. The other difference I'd point out is that as of October 2012, you can't use a LoadMaster if you've got an NLA, a network level authentication infrastructure policy in place. Connection Broker will play well with that, but it's not going to be such a good place for a LoadMaster because that's going to negate one of the key things that we're doing, which is that service awareness and the health checking that a LoadMaster does. At least today, we haven't figured out how to do the network level authentication to get that health checking. So you can still do layer 4, layer 3 health checking, but for the service aware stuff, you're not going to be so happy. So Connection Broker might be a better answer for that sort of situation.
Kind of following on from that question, talk a little bit about the reporting tools. So for the hardware load balancer you've got, if this person wants to get historical data, what kind of reporting tools exist for getting that data?
Okay, LoadMasters, that's great. LoadMasters have a number of industry standard ways of getting information, and both runtime as well as historical. We're fully SNMP instrumented, and that SNMP instrumentation is a nice bridge into Microsoft System Center, so folks who are our System Center reference customers can actually get really good visibility on everything a LoadMaster is doing through System Center, through SNMP. There are folks that are doing roll-your-own things like MRTG, and that will also use our SNMP instrumentation to get that. We've got full syslogging, and folks have a variety of third-party tools that they'll use with remote syslogs to do network management and to do trouble paging, and it integrates well.
Well, Jonathan, I want to thank you for spending some time to talk with us about not only just the Kemp technologies, but also some of the great practices in load balancing RDS in general.
This has truly been a pleasure, and I'm appreciative for this forum for folks to take a few minutes and just think through. Again, if I'm going to leave folks with anything, it's think through what the business and technical goals are, because that's going to really narrow your decision tree at the top, and it's going to make a lot of other things a lot simpler.
And so with that, I think I'm going to turn things over to Chris Flock for some final comments.
Hey, thank you so much, Greg, and thank you so much, John. Much appreciated today. Appreciate you guys taking your time, everybody in the audience, for joining us today. I did have a few questions from people in the audience about where they could download their slides. There's a resource tab right down there in the dock on your console screen. You could click on that and you could download the slides there. So make sure you do that before the webcast closes today. And also don't forget to take down their links and their slide right there and how to get Kemp LoadMaster. So copy down those links and make sure to visit the website. But thank you all for joining us for today's webcast, which has been sponsored by Kemp. We appreciate your time, and have a good day. Thanks, everybody.
That does conclude today's conference. Thank you for your participation.